Hello everyone, welcome back to physics classes by Harish, and today we are going to discuss about the dimension of physical quantities. So part 2 in NEET crash course 2021, chapter 1 units and measurements, part 2 video we are going to discuss it here. Dimension of physical quantity. So what is dimension? Here dimension is nothing but power to which the fundamental quantities are raised to represent the physical quantity. Let us take any physical quantity. That physical quantity we have to represent in fundamental quantity, as we know that derived quantity depends on fundamental quantities, right? So to represent the derived quantity in terms of fundamental quantity, we have to raise the power of the fundamental quantity. So that is nothing but dimensional formula of the physical quantity we can write. So dimension for fundamental quantities, we have the fundamental quantities according to this mechanics, mass, length and time. Mass, length and time are the fundamental quantities. Dimension of mass is capital M. So dimension formula always we have to write in square brackets with capital letters. So mass is M and length is L and time is T. So for example, we can see here dimension of the force. So to write the dimension of the force, we must know that mathematical relation or unit of that physical quantity. Then only we can write the dimension of the particular quantity. So here let us take a physical quantity force. Its SI unit is nothing but kg meter second minus 2. Kg meter second minus 2. Based on that, kg represents the mass of the object and meter represents the length second inverse is nothing but time duration, we can say that. So based on the unit kg meter second minus 2, we can write the dimension of the force m. For kg it is m, for meter L, and time second t minus 2. So dimension of the force is ml t minus 2. So second one is nothing but energy. Energy SI unit is kg meter square second minus 2. Similarly, we can write for kg m, meter square is L 2, and second minus 2 is t minus 2. So this is the way we can write the dimension formula of the given physical quantities, right? So I'll write again a few more physical quantities. Let us take linear momentum. Linear momentum P is equal to mv. So here m is nothing but mass, v is nothing but velocity. Unit is nothing but kg meter second minus 1. So dimension of linear momentum is m l t minus 2. Okay. Likewise, torque tau is equal to rf. Okay, then it will be unit is Newton meter. This we can write as kg meter square second minus 2. The dimension formula of the torque is m l square t minus 2. So okay ma. So this is the way we can write the dimension of the given physical quantities. Okay, and we'll solve one question on this. Given two physical quantities P and Q, its dimension formulas are as follows. Given dimension of P is equal to, dimension of P is ml square t minus 2. ml square t minus 2. ml square. No. Given product of two physical quantities dimension is ml square t minus 2. ml square t minus 2. and ratio of and dimension of two physical quantities is ml0 t minus 2. Then dimension of two physical quantities is, okay, so here it is given PQ. Dimension of PQ is given m L square t minus 2. Let us consider P comma Q are the two physical quantities, and P by Q is given m L0 t minus 2. So we have to find the dimension of P and Q. So here if you multiply these two, let us, this is equation 1, this is equation 2. 1 into 2. Then it will be PQ into P divided by Q is equal to ml square t minus 2 into m L0 t minus 2. So this Q will be cancelled. Finally we will get P square is equal to m square L square t minus 4 will get. So then dimension of P is m L t minus 2 will get. T minus 2 will get. So next dimension of Q we have to get it. Okay. So then dimension of Q is equal to, substitute that dimension of P in this PQ. So then dimension of Q is equal to dimension m L square t minus 2 is divided by dimension of P m L t minus 2. So then it will be m will cancel, 1 L will be remains, t will be cancelled. So dimension of Q is equal to L. So this is the way we can find the dimension of unknown quantities. Dimension of unknown